This is the second part of Wednesday's assignment. It is graphing rational functions. So that shouldn't say polynomials because now we are graphing rational functions. And so when we're graphing rational functions, it's going to look something like example 1. And since rational functions is like a fraction, we have to realize that this function is going to be undefined at some value of x. So when it's undefined, that is going to be where an asymptote will lie. And remember, an asymptote is like these orange lines. It's an invisible line that the graph, which is the blue line, approaches but never touches. So here's a summary of how we're going to graph rational functions. So the vertical asymptotes are going to be wherever the denominator is equal to 0. So that means we're going to set the denominator equal to 0 and then we're going to factor it. Horizontal asymptote is going to depend on the degree of the numerator and the degree of the denominator. So if the degree in the numerator is less than the degree of the denominator, then our horizontal asymptote is going to be y equals to 0. If they're the same, so that means the degree in the numerator is the same as the degree in the denominator, that means we're going to take the leading coefficient of the numerator, which is a, divided by the leading coefficient of the denominator, which is b. And then if the degree of the numerator is bigger than the degree of the denominator, then there's none. So that means there's no horizontal asymptote. So if there's no horizontal asymptote, that means there's going to be a slant or an oblique asymptote. And slant and oblique asymptotes mean the same thing. And in order to figure out where the slant or the oblique asymptote is, we're going to use synthetic division or long division. And the reduced polynomial is the slant asymptote. So now we kind of know how to find out how to graph rational functions. Now we're actually going to look at the examples. So example number 1, I'm first going to find my vertical asymptote, which means I'm going to set the denominator, so negative 3x squared plus 9x, equal to 0. And then I'm going to factor this. So I'm going to look at these two terms and I'm going to notice that I can take out or factor out a negative 3 and an x. So when I factor out the negative 3x, the first term I'm just left with x, and then the next term I'm left with negative 3. So remember, if I factor this, or if I multiply this back out, negative 3 times x is negative 3x squared, and then negative 3 times negative 3 is positive 9. And that's equal to 0. So now I'm going to set the first factor, negative 3x equal to 0. And that means x is equal to 0. And then I'm going to set the next factor, x minus 3 equal to 0. And that means x is 3. And that's a 3. So that means my vertical asymptotes are going to be at x equals 0. So that means I'm going to have a dashed line when x is 0, so like so. And then when x is equal to 3. So right here and here. So now I have to figure out if I have a horizontal or if I have a slant or an oblique asymptote. So remember, I'm going to look at the leading degrees, and my leading degree for the numerator is 2, my leading degree for the denominator is 2. So I'm going to go back to my chart and I'm going to look at this second row because they're equal to each other. So that means I'm going to take the leading coefficient of the numerator and divide it by the leading coefficient of So that means my leading coefficient of my numerator is 1, and the leading coefficient of the denominator is negative 3. So that means I'm going to have a horizontal or slant asymptote or an oblique asymptote when y is equal to negative 1/3. So that's going to be about right here. So I'm just going to draw my horizontal asymptote right here. And it should be a little bit closer to the y-axis, but I'm doing it on my computer, so it's a little bit off. So now I know where my vertical asymptotes and my horizontal asymptotes are. I need to figure out where the graph is actually going to be. In which section is it going to be? So in order to do that, I'm just going to randomly pick x values. So I'm going to pick an x value that is to the left of x equals 0. I'm going to pick an x value when they're in between 0 and 3. And then I'm going to pick an x value that's outside of or to the right of x equals 3. And it doesn't matter what x values you pick. I'm just going to pick for my first x value, I'm going to pick negative 1. So if I do negative 1 squared minus 3 times negative 1 minus 4 divided by negative 3 times negative 1 squared plus 9 times negative 1. So we have negative 1 squared, which is 1, negative 3 times negative 1, which is 3, so I have 1 plus 3 minus 4, so that's 0 on top, and it doesn't matter what's on the bottom, but that's negative 3 minus 9, negative 9, so that's negative 12, but that's 0, so negative 1, 0 would be about right here. So that means my graph is going to be something like this, and it's going to approach this red line, but it's never going to touch. Okay, now I'm going to do the same thing. So I'm going to pick an x value when x is between 0 and 3. So I'm going to pick 1. So I have 1 squared minus 3 times 1 minus 4 all over negative 3 times 1 squared plus 9 times 1. Hold on 1 second, I have to answer the phone. I apologize for the delay. So on top I should have negative 6, and then on the bottom I should have positive 6, so then that's going to be about negative 1. So 1, negative 1 is going to be right down here. So then I know my graph is going to look something like this. And now I'm going to pick one last point. It's going to be when x is greater than 3. So I'm just going to pick like 4. So I'm going to have 4 squared minus 3 times 4 minus 4 all over negative 3 times 4. Hold on 1 second. My dog is running around. I'm back. I apologize. So, as I was saying, times 4 squared plus 9 times 4. Okay, so if I evaluate the top more, I have 4 squared, which is 16, minus 3 times 4 minus 4, which is 0. So it really doesn't matter what's in the denominator since the numerator is 0. That's going to equal to 0. So I have 4 comma 0, so that's going to be about right here. And that means my graph is going to look something like that. Sorry. My purple graph right here should be a little bit smoother, but since I'm on the computer, it's a little bit harder for me to draw a straight line. But that is what example 1 should kind of look like with vertical, horizontal asymptotes, and then your graph is in purple. So now we're going to move on to example 2, and for example 2, I'll go ahead and find the vertical and horizontal or slant oblique asymptotes, and then we'll graph it. So remember vertical asymptotes, you're going to set the denominator x squared plus 3x equal to 0. And then we're going to figure out where x is undefined. So I'm going to look at my two terms, and I should notice that I can take out an x or factor out an x, so that means I have x plus 3. So that means my first factor is x, so that means x is equal to 0. And then my next factor is x plus 3 equal to 0, which means that x is negative 3. So I'm going to have two vertical asymptotes, one at x equals 0, right here, and the other one at x equals negative 3. Okay, now I'm going to find my horizontal or slant asymptote. I'm going to look at the leading degree of my numerator and my denominator. So the leading degree of my numerator is 1, my leading degree of my denominator is 2. So that means that my horizontal asymptote is going to be at 0. So that's easy. So now I'm just going to draw a purple line at y equals to 0. Right there. So now I'm basically going to do the same thing I did for the last one. I'm going to pick 3 random x values, one that is to the left of x equals negative 3, one that's in the middle, somewhere in this section, and then I'm going to pick another one that is to the right of x equals 0. So my first point I'm going to pick is negative 4. My first x value. So 2 times negative 4 minus 4 over negative 4 squared plus 3 times negative 4. Okay. So that's negative 8, and negative 4 is negative 12. Over negative 4 squared is 16, plus 3 times negative 4, which is positive 4. My apologies. So that means negative 12 divided by 4 is negative 3. So negative 4, negative 3. So I'm going to draw my graph. My graph's something like this. And something like that. Okay, so now I'm going to pick a point that's in between negative 3 and 0. So I'm going to pick negative 2. So I'm going to have negative 2 times 2 minus 4. So that's minus 8. And then I'm going to have negative 2 squared plus 3 times negative 2. So then the 2 squared is 4. 4 negative 6 is negative 2. So then that means it'll be positive 4. So negative 2, positive 4. So it's going to look something like this.